Hello, everyone from Kurawa Software Operations. My name is Elie Assi. I'm a senior DevOps engineer at Kurawa Software. And on daily basis, we work at Kurawa with cloud-based services like Kubernetes, AKS, and a ton of automation tools like Ansible, Puppet, Terraform, and a bunch of other things. I live in Bilbao in Spain. And like I said, I'm part of the DevOps team at Kurawa Software. Kurawa itself is part of the Bystronic group. Bystronic is a Swiss company that produces machinery made for bending metal sheets, for cutting metal sheets, for automation, for robots, a bunch of other things. We are working with the Bystronic group as part of Bystronic group rather, to build a smart factory, which is the entire software solution from giving codes to the actual delivery day of the product to the market. That's controlling the robot on the factory floor to get codes, to get everything. A lot of our software is based on factory, and some of it is also based cloud-based that are for our multi-tenant clients. One of the projects that came up recently, by the way, these are the machines that are produced at Bystronic. That's part of them. These are cutting, bending. This is part of the automation on the shop floor factory. One of the recent projects that we have been dealing with is called CamData, a project that's between Kurawa and Bystronic. This service is cloud-based and is multi-tenant. We wanted to containerize this software and have it hosted in the cloud. Apart from the software itself, the backend is a MongoDB, and also we needed a Mongo Express to be able to have a UI for the teams to be able to do any changes inside the MongoDB itself. This is a resume of what we wanted to do. Pretty much, this is the project itself. Our first approach was actually to use virtual machine Azure as every project starts. We wanted to use a virtual machine to do our testing and evaluate the infra, how well it will be in production with relation to being in virtual machine, how it will scale up, etc. So we went for a basic setup in Azure with a normal with a public IP, a VM. We went for managed disks to be able, if something happened to the virtual machine, to be able not to lose the data. Our logging solution also was linked to that, so logs can be transported from the machine outside for a development team to be able to view the logs. We containerized here our application itself. And we wanted also to make MongoDB and Mongo Express into containers as well, because we didn't want to deal with the actual operating system itself and its dependencies. We wanted our applications to be easy to deploy within containers. We had some challenges with this. The first challenge was related to scaling. Or scaling fast enough. As you can see, we had a couple of virtual machines and high availability, but as this service will be multi-tenant, our first challenge was to see how we can scale this up depending on usage. Not as easy in virtual machines as in Kubernetes. Apart from this, as we have the databases inside the virtual machine, each running in a container, we wanted a solution to be able to replicate the DB between the different virtual machines that are running, and with every new virtual machine that comes up to support a new load, we wanted this to have the exact same replication of the DB that's running on the previous machines. Another problem that we had was maintenance, that all the maintenance that had to do with the virtual machine, whether operating system updates, whether with deployments, whether with, like I said, with high availability. All these things had a negative effect in our test, on our performance testing and our CI environment. So we decided to go for, or at least to give it a shot to see how we can replicate all of this into Kubernetes. We already have several Kubernetes clusters running in our development and production environments, running several of our applications. So wanted to give this a go. We have not used MongoDB or actually stored databases on Kubernetes before this. We have our own applications that are running, but the backend has always been as a SaaS in Azure, for example. So this was a bit of a challenge for us, and I'm going to tell you a bit how we went about it. The move from the virtual machine to Kubernetes itself. So our first challenge was actually we already had the virtual the image of the application in a container already. So moving that to Kubernetes was an easy task, having the images already being produced in our own pipelines with our own Docker files and pushed to our ACR. So having those images deployed to the Kubernetes cluster, which we already have in our ACR, was not a big deal for us. That left behind, obviously, database and MongoDB on the virtual machine. The most scaling that we wanted was actually for our front end, for our main application, let's say, because that's what's going to scale up, and the database is gonna have more or less the same size, while the other pods keep on scaling depending on the load about them. So we didn't want to leave our MongoDB and Mongo Express inside virtual machine. We wanted to move everything to Kubernetes apart from solving the scaling problem that we had in virtual machine for the application. Here we went for the Mongo Express. We used the Helm template to be able to deploy Mongo Express, and we also used the Helm template to be able to deploy MongoDB. The traffic, as you can see, goes through from the browser to the Mongo Express. So our development team is able to configure the database and create tables and do any changes that they need from it to inside MongoDB. MongoDB itself obviously is not exposed. The Mongo Express has its own ingress controller, and inside the Mongo Express deployment, we have the secrets and the config map to be able to connect to the MongoDB itself that's running as an internal service. We use Helm chart, like I said. We use the Bitnami Helm chart for MongoDB. We installed it fairly easily, and then for Mongo Express itself, we used this repo to be able to install the same release of Mongo Express into the Kubernetes cluster itself. So our own workflow went pretty much from stage one was to do our tests in our CI environments with virtual machines, etc. Then when we wanted to think about scaling, we moved to Kubernetes, and then we automated the entire process of deployment of our application, deployment of MongoDB, deployment of Mongo Express, all through our Azure DevOps pipelines that we will see in a bit how we do this part. Let's switch on a bit to the technical part. I split this up into 4 parts for this demo. I want to talk in the first 2 parts briefly about our application, and then the MongoDB and the Mongo Express. Our application, which is part of this entire project, it's split into 2 parts. The first part, we create the image itself and we push it into our ACR. And once the images reside there, we are able to deploy those images with our templates to the Kubernetes cluster. Yeah, as you can see, this is a basic Docker file that we use to be able to build our image, run our tests. And then once this image is created, this entire process is automated in our pipeline. So as soon as a pull request happens, the pipeline will run. This will run when this is successful. The image will be pushed to the ACR. The second part is actual deployment of the application. As you can see, we've created 4 files that we use for our deployment. The deployment one is what we use to deploy this is we first pull on the image that we create with the Docker file, for example, from our ACR. And then, as you can see here, there are values that are not specified. These values, like the image tag, the replica number, sensitive values here, database URL, database name, etc. All of this is not hard-coded into our templates. These gets replaced on the moment of deployment. So within our deployment pipeline, the first step is to always look for these variables defined between these two symbols here, and then do a proper replacement. And once those files have been replaced correctly, the deployment will happen directly from the pipeline. So this is the deployment. We're exposing the portal application, our metrics port, to be able to grab metrics into Prometheus and Grafana. Our resources that we also limit, both limits and requests that we are able to easily change after with variables, and also the health probe that we have for this application. So any new deployment that happens and new pods that go up will have this dash health being checked before the deployment finishes correctly and the older pods are removed. Lastly, this as we have two different node pools in CI, for example, and in production more than once, some of them are Windows and Linux. This application is on a Windows-based container, so we want to make sure that any deployment that happens goes directly to the Windows node pool. So we specify the node selector part in here for that. The ingress is pretty basic, as you can see in here. The URL, and then we specify our annotation for Cert Manager to be able to grab the proper certificate for this ingress, the namespace where we deploy this deployment to, and then a service that will connect to the deployment and expose the correct ports to be able to connect to this application. So we deploy, like I said, our application. This is how we build it, and we deploy it to Kubernetes with these templates. Then for the more interesting part, the MongoDB we use, like I had mentioned, the Helm chart. There are some things that we do change from the default value. I'm gonna go through them a bit with you guys. So the first part that we do actually change is the architecture. We use standalone architecture for our CI environment. Then the authentication part, the root user and root password for the MongoDB that you need on the moment of creation, we specify and also gets replaced on the moment of deployment in here, these two values. Also the username, password, and default databases that get created on the moment, because we don't want to use the root user and password for operations from our application. So we generate another username and password and a database for the application. Another interesting part in here will be, if we scroll down a bit more, is the service part. Obviously, this gets deployed to a Linux node pool. So here we specify with the node selector that we want to use the Linux node pool to deploy this from. This only needed in case you have several node pools of Windows and Linux, and you want to make sure this always goes to the right one. If you only have Linux, you don't have to worry about setting up the node selector part. And if we scroll down a bit more, we specify the resources, the limits, and the requests for this deployment. Usually we adjust this after based on what we see in Grafana from the metrics that we get. And the persistent part is by default set to true within this template. And then the interesting part is the service that we configure to be able to connect to this MongoDB. We use a cluster IP, so we want to access this MongoDB only internally from inside the cluster. We don't want to have it exposed externally, especially since our application runs within the same cluster. So our application that needs to access this MongoDB will access it internally from within the cluster. It will store data internally within it. Same thing for the Mongo Express, that it will connect internally to the MongoDB and then have its own ingress to be able for developers to be able to do changes to the database itself. So here you specify the type, which is cluster IP, and the port that will be open. And then this is how we connect to the database. External access is disabled, so we're not deploying any load balancer IP or public IP for this database. And then, like I had said, the actual persistent is set to true within this template. There we go, persistent enable true. If we move on to the Mongo Express part in here, we can see also some interesting stuff. It uses the Mongo Express official image in here, and we scroll down a bit more. We're also, the service is cluster IP, and this is the port of the service for the Mongo Express. We specify the ingress enabled as true because we want to have our own ingress to be able, our own UI to be able to access this this Mongo Express. We limit the CPU and memory with our limits and requests. The same thing with node selector as earlier. This is the Linux container, so we want to make sure it's running on the Linux one. And here is the interesting part that it needs to connect to the Mongo server, which is running internally on this cluster. Here, instead of specifying the IP of the service for the MongoDB, obviously when a service gets deployed, it gets assigned its own private IP. But imagine there's a case that we have to remove the service or remove the application or redeploy. This is bound to sometimes maybe change this service IP, this internal IP. So we wanted to use instead the internal DNS resolution of this service, which will not change even if the IP does change. So we're going for MongoDB .sv.cluster.local, and this is how the Mongo Express is able to find the MongoDB internally on this service and on this port, obviously. It also will need the MongoDB username and password to be able to connect to it. So we find it with this local DNS entry, and then to be able to authenticate and write data or access it, we need obviously the credentials, which are also specified in here, that gets replaced on the moment of deployment. If we have a look at the service that we're talking about. So this is the service itself. It's using a cluster IP, and this is the IP that I was referring to. The Mongo Express will try to connect to this exact service on the name itself for the internal DNS resolution to be able to find it. The same thing with our application. It will connect with the MongoDB, with the MongoDB service, with the actual name internally instead of the actual IP here. And then, as you can see here, this has been running for around 247 days. So it's been running for quite a while in our CI environment without any issues. We went through several changes in the cluster, several Kubernetes upgrades, several deployments, several recreations, and the data has remained intact every single time with the persistent storage without any issues that we have. So, speaking of it. This is the persistent storage that gets bound to this. It will come up. In the meantime, this is the Mongo Express itself. This is the UI, and here this provides our developers a portal to be able, if they want to check in it and create a database, do any change to be able to access. Of course, this is protected with the login details. So for that part. And as you can see here, the persistent storage is bound to this very deployment for, we're using only 8 GB. This is a value that can be specified in the template itself. For CI, it's more than enough size for us. That will also depends on your need, but this value is also specified within the Helm template itself. Okay, for the final part, so our takeaways from this experience that we've had, that having Helm makes everything very easy, especially for stuff like MongoDB or Mongo Express, not to have to write our own templates. And with a few changes that you have seen, we can deploy a MongoDB with persistent storage, with all that very easily with just a few changes to the values depending on our needs. Obviously, this entire endeavor, you need the entire Kubernetes ecosystem to make everything easier, because you're going to make use to host this application and to host this database. You're going to need your stuff, your other stuff in Kubernetes. You're going to need your cluster. You're going to need your ingress controllers. You're going to need your cert manager. You're going to need your Prometheus, your Grafana to get data. So obviously, starting from scratch, it's a big project to create Kubernetes and then deploy an application, but having that already existing, which we did, that of course made our life easier. And within a day, we were able to create these resources and add them to our already existing cluster. And like I said, we need more tools for this application to be able to monitor it correctly, for everything to work correctly, not just these, but that's how things go. And the last takeaway that we have is that it's more cost effective. We compare to having virtual machines running, in our case, to host this application, having this in pods and Kubernetes, it's far more cost effective for us. We don't have to worry about having several machines for high availability. We don't have to worry. We have to worry about far less things, and also it's much more scalable, easily changing our value for a replica set, or having a horizontal pod autoscaler. We can control, since we get metrics to that, we can control scaling up and down our application. This doesn't really apply that much for our database, let's say, or the Mongo Express, but for our own application, this definitely applies. And for last bit, I want to thank everyone, to the community, and have a great day.